of a constitutional right, it's a very complex issue because we need to establish a cause and effect relationship between the entrenchment of the right and the achievement of the intended outcomes. There are a myriad of variables that we need to be considering. For example, the rule of law, socioeconomic conditions, and in the case for the right to food, we also need to consider a country's food balance. Instead, we decided for a more direct approach to determine whether the constitutional right to food has been subsequently incorporated into policy, law, and court decisions. And if that's the case, how have the branches of government done so? How have they understand and developed the right, and what are the gaps and failures that could reveal opportunities to improve the implementation of the right to food? So why do we need constitutional entrenchments of the right to food or any other human rights if we already have international human rights law? This is a question that sits at the foundation of my research and a question that I get to ask every time I speak about these topics. And a quick answer is because one is not enough, we need both. The human right to food was first recognized in the Universal Declaration of Human Rights in 1948. And 2 decades later, the right was further developed in the International Covenant of Economic, Social, and Cultural Rights. It was adopted in 1966. And it has been ratified by 171 member states. This means that the majority of the countries of the world are obliged to the maximum of its available resources to progressively achieve the full realization of the right to food, to immediately guarantee non-discrimination and non-regression in the exercise of the right to food, and to immediately meet the minimum essential level of the right to food, which is to be free from hunger. If states do not comply with these obligations, there are international instruments, mechanisms, and procedures in place to make states accountable. This is fantastic, right? Yet people that are hungry live in states that are state parties to the covenant. This is because ratification does not mean realization, just as constitutional entrenchments doesn't mean the implementation and achievement of outcomes. Oh, imagine a map. So in the map, what is shown is that very few states are not part of the covenant. They are in orange, and they're in different shades of blue, which is most of the planet in blue. It's the states parties that are part of the covenant. In very hard blue, dark blue is the states that have high food insecurity, and the progression to lighter blue, it's the states that have no food insecurity. And this could serve as an example of the limitation of international human rights law, but from a more practical point of view, this map, in your imagination, also highlight the importance of discerning ways in which national systems could help international law to advance towards the elimination of hunger within equitable, environmental, and healthy parameters. The current content of the right to food is developed in the General Comment 12, and it reconciles historic tensions between food availability and food accessibility. And the right to food, according to the General Comment 12, the right to food, it's about both, and both sits at the core. And also, the General Comment 12 clarified other fundamental aspects of the right to food. The General Comment states very clearly that we all have the right to food, but marginalized populations come first. That governments are obliged to respect, protect, and fulfill the right, that businesses are responsible to respect the right to food, and that there are procedural rights that are complementing the right to food. And this is access to information, access to justice, and public participation in decision-making process. So in order to select the countries, we did a different stage approach. So the first one was, out of the 30 countries that have included the right to food in the constitutions, we discarded fragile states, just because the rule of law and the democratic institutions are so weak that rights are very unlikely to be implemented. So for the remaining 22 countries, we conducted research to establish inclusion years and the exact wording of the constitutional provision. And this will provide us a baseline to conduct further studies. For the final step, we conduct quantitative and qualitative analysis, and which indicated that Bolivia and Mexico were relevant candidates to study further. Now, for the last part, I will talk about the results. First, as a prerequisite of implementation, we conducted research on right to food enforceability within the Constitution. We found that in both countries, the constitutional right to food is a self-executing right with high enforceable potential. Continuing with our results, we found that the explicit constitutional inclusion of the right to food is an effective way to advance the rights realization because it has triggered actions to implement the right to food, including in Mexico, 7 laws, 5 policies, 5 court decisions were enacted, and in Bolivia, 4 laws, 6 policies, and 3 court decisions. We also found that both countries possess a comprehensive understanding on the right to food, and implementation efforts clarify operational parameters. For example, in Bolivia, the Bolivian Constitutional Court established that allocating public funds to implement the right to food is not an option, but a state's obligation. In implementation efforts also address food accessibility and food availability, and implementation efforts consider the 3 adequacy dimensions: health, social, and environmental. The health dimension was the least considered, yet there are interesting advancements. For example, citing the right to food, the Mexican Supreme Court upheld amendments to a Mexican tax law that imposed 8% tax on sales and imports on unhealthy foods. Despite these positive developments, we found that there are legal gaps and systemic implementation challenges that undermine the potential of the right to food. Legal gaps include food loss and waste, completely neglected, populations in detention, victims of conflict and food system workers were overlooked, gender equality was very poorly addressed, business-related topics remain in need to be more extensive regulated. Right to food defenders' protection was also neglected. So finally, I want to conclude in these last minutes that I have by saying that in these 2 countries, the wheels of the legal systems are turning. Yet these are not the only metrics by which success should be measured. These legal developments are only a means to an end, and the end is the full enjoyment by all people of all universally recognized human rights, and we are not there yet. Therefore, it is key to continue developing academic efforts that assess the effectiveness of human rights. Thank you so much.
Okay, so today I'm talking about a project.
Emily.
Oh, yeah. Sorry, thanks, Carole. Here we go. I'm trying to be really fast. Thank you. I'm Emily. I work at Emory University. Today I'm going to talk about a project with some amazing colleagues that's very much in progress. The hopes of presenting it to you guys today was that you could ask brilliant questions if we had time, but maybe over lunch, and give us feedback on this hard thing we're trying to do that I think we're all trying to do, which is kind of this big motivation, I think, for the whole conference. It's why we're all here. I think we've come to a place where we agree major transition is necessary and inevitable. We're talking about agricultural transition in this session, but broadly across many socio-environmental systems, radical change is needed. So where do we want to go? Given where we are, how do we get there? And something I'm thinking about a lot is how do we, as researchers, help support transition? So I came across a paper a few years ago that kind of outlined a way of thinking about this that's simple, but I think pretty helpful in terms of how you can contribute as a researcher. I think a lot of the work we do is understanding what is. There's a lot of work that I'll talk about today trying to articulate what could be, but I think even more important is trying to understand what should be with diverse stakeholders, and then doing the very, very hard work of creating a renewed what is. The problem we've been thinking a lot about is how do we understand how agricultural land use will change? And you guys know where we grow food is a function of sun, soil, and water, but it's also all the messy people stuff that we're all really interested in. So things like farm-level decision-making and management, political economy, presidential elections, all these things affect agricultural landscapes. So we actually have pretty decent projections for how sun, soil, and water might change in the future. What's really hard, there should be more mind-blown, mind-melting emojis here that just didn't come through. This stuff's really hard to anticipate. So this was the motivation for the whole project I'm going to talk about. So we've been modeling we have really good agricultural land use data in the US, so we've been sort of using big machine learning models to try and understand how where we grow these major crops will shift in the future. The models are like stupid big, where it's too many crops, too many predictors, but we have a lot of those messy people stuff predictors in the models, and we can see some really interesting things without engaging stakeholders yet. So one thing we're able to see is we can look at the variables that play an important role in predicting where major crops are grown. And if you know anything about the United States, you know that about 60% of what we grow is corn and soy. And if you add wheat, you get up to about 80. So we have like profoundly simplified landscapes. Corn and soy, if you look at what predicts where they are grown, it is overwhelmingly input use and federal subsidies. Climate is less important than these actionable human levers we have. And I think that's an important finding. The other thing that I think is really important, this is just showing the roles of different predictors in predicting where corn is grown. It gives you a sense of like the directionality of importance, but basically like the top predictors for corn are indicators of phosphorus, nitrogen, chemical application. You get eventually to like max temperature in the warmest month, but again, like decisions we are making about how we manage land radically shape how land is managed, and those are things we can change. This is the good news. But so all these sort of big data models are fun and I think help us understand the bounds and direction and like magnitude of future change, but they really only get us to this kind of probable futures if the system keeps chugging along, or like maybe we start to get into this range of like this sort of distribution of what landscapes might look like in the future. But what we're really interested in is these preposterous futures, these crazy surprises that we can't anticipate. And the most important thing is this preferable future, whether it lurks and lives within the probable or if big changes need to be made to move the system in the direction of better. You guys know this, but to me, this is one of the biggest challenges in this agricultural futuring space. We're really good at predicting the probable, like if the system keeps chugging along, what might happen. And even then, it's quite hard. But all the models, many of the models we're using are calibrated on historical patterns and trends and structures, and they're very bad at anticipating future surprises. The other huge issue with all this modeling work is they don't often articulate the desirable, which is so important, and often sort of culminate in these specific interventions instead of strategically linked interventions that actually leverage systems change. So we were kind of sitting with this after modeling a lot of land use change and thinking like, well, how do we get to these surprises? And what we've been experimenting with is a combination of sort of stakeholder engagement tools. One's called Delphi surveys, where we're iteratively engaging experts to parameterize, quantify their expectations about the future. But then we realized deeply there are many things we simply can't quantify, and so that's where we're doing lots and lots of farmer engagement in 3 U.S. states to kind of do a social downscaling of our big data models in place based on the lived realities of people and farms. These are just starting, and they're really fascinating because we're starting to see things our models miss. So things like emergent technologies and management practices that could fundamentally shift how crops respond to climate. Big shifts in public policy, again, the role of policy in shaping, radically transforming agricultural land use in the U.S. cannot be understated. So it's a tremendous lever. And all of these adaptive frictions that play out at the farm scale that affect what's actually grown and how a landscape is actually managed. And then the coolest thing that I find really exciting, we're doing this a lot in the state of Georgia where I live, is getting really diverse people together. Urban farmers in Atlanta and like cotton growers from down in the southwestern part of the state to have these conversations about, here's what we know about the probable, how does this intersect with the desirable, and what would this mean for your farm? And these conversations have been really cool and I think really formative in starting to build the networks and glue you need to make transformation happen. I guess the thing I've learned in this, like this started as a big modeling project, and now I'm realizing the models aren't the goal at all. The goal is to actually use these models as boundary objects to start to structure conversations about the future. So when we talk to stakeholders, we're very clear that these are models, they're probably wrong. What did we miss? Tell us what you know. And we get really rich insight from that. But then we're still into modeling, so we're also trying to bring this back into the models. And so a way of kind of visualizing what we're trying to do is we do this sort of sun, soil, and water into the future for major crops. And then through stakeholder engagement, we're able to kind of like redefine, stretch out the probability distribution based on what they tell us. So corn in this region is looking like these specific innovations might change how we grow it, and it could actually make it easier to grow corn here in the future. This kind of gives us an updated distribution of what a crop's viability might look like in a region in the future, and then we simulate hypothetical landscapes and place farmers in those landscapes. So we do have some modeled results with their input that tell us something about the future. Does that time up? Oh, 30 seconds. Cool. So I just said that. The main thing, I'll close. I'm basically done, but like, this is the thing I'd love to talk about with you guys during lunch, like whenever, over mezcal later. Like, this is hard. I don't know how we move from where we are with these models, where we've done all this work to engage stakeholders, to get to this next place of like stirring up new imaginaries and making change happen. So we're putting a lot of money and effort into strategically converging key players to try and make change happen in US states. But I think there's a lot of work that this community could do, and probably is actively already doing, to try and figure out how you can strategically bring people together to pull levers and make systems actually move in the direction of the desire they articulate. So I'll stop there. I had one more slide, that's pretty good. There's a session this afternoon where we're digging into this a little bit more at 4 if you want to come. But yeah, thanks for your attention. Thanks, organizers, for getting this going. I don't know who's next, but...
Thank you so much, Emily. Yeah. We have time for one question for Emily. Let's do it. You know, we're going to be a bit late for lunch, but that's good. Yeah, over there. You just have one mic. Come to you.
Oh, I still need this, I guess, don't I? Yeah.
Hi, thanks for the talk. That was super interesting. So I have a question about integrating feedback into the models. Kind of a two-part question. One, how do you take the qualitative data that you get and turn that into something that can be quantified? And then, is there any chance for a longitudinal aspect of that quantified stakeholder data that can be kind of continually fed back into the model for further optimization and have the longitudinal aspects?
That's a cool idea. So the Delphi surveys help with that. It's like qual-quant. It feels and looks like a survey. So we're actually getting folks to converge on an anticipated shift. What's the likelihood that irrigation will expand at the rate it's expanded in the last 20 years in the state? And so we converge on a number, and we can wiggle either the predictors or kind of the functional infrastructure of the models to update the projections based on the Delphi results. Though, to be completely transparent, we're kind of experimenting with this, so we don't really know. I don't want the focus groups to necessarily fit into the model. I think the focus groups are going to help us see intersectionalities the models can't see. So, for example, talking to Black farmers in southern Georgia who have problems accessing the federal resources that our models say are predicting where certain crops are grown, that kind of stuff, there are ways we can weave it into the models by basically manipulating predictors. But I actually think we're going to use that as a way to explain the caveats and limitations of our models and articulate the things we can't see, because we don't think these models are going to catch everything. I really like your idea about longitudinal engagement, and I hope that's where we get funding pending, right? Because it'll take more engagement. But I think at least in Georgia, there's a lot of buy-in of trying to do this right. So I'm optimistic we can keep that going. That was a really good question. Thanks, man.
All right. Thank you, Emily. That was efficient. And looking forward to discuss more. Thank you so much. The next speaker is Julie Fortin.
Cool. Thank you. Hi, everyone. My name is Julie. I am a PhD student at the University of Hohenheim in Germany. My thesis is part of a broader project called the Bright Spots Project. So the main idea of Bright Spots is that while we agree that the food systems require transformation, we believe that there are already places out there that are sustainable right now. And we call these places bright spots, and we want to find them, and we want to learn from them. So in order to find bright spots, we need to quantify sustainability. So what we're doing is we're basically mapping sustainability at subnational scale in our study regions of Mexico and India. And we're going to find subnational regions that are positive outliers. So the sustainability scores are higher than you would expect. And these will be our bright spots. But what do we mean by sustainability? How do we quantify it? It really depends who you ask. A lot of people have studied this before. There's a lot of lists out there. Here are just a couple examples. But there's also a lot of evidence that it really matters that you engage stakeholders, similar to what Emily was saying, and ask people on the ground what matters to them. So that's what we did in Bright Spots. We asked people what their visions of a sustainable future food system would look like in the year 2050, and then we asked them, what should we track to measure progress towards that vision? We ran these workshops at the national level and at the state level for 2 different states in each country. For now, I'm only presenting results for India. But here's some examples. So we had some overlap in the indicators that were brought up in the different contexts, but there were also some indicators that were unique to each. Sorry, I'm going through these slides real fast. In addition to the workshops, I also started doing a little bit of a review of indicator frameworks in the literature to be able to compare. And a couple interesting findings that I've had so far, very preliminary, is that economic indicators happen to be disproportionately important to local actors in India compared to the literature, which was more balanced in terms of the dimensions of sustainability. And also, in the literature, the production sector was a lot more heavily represented, whereas in the workshops that we ran, it just happened to be more evenly distributed between production, consumption, and the supply chain. So what are we going to do with this? We're going to calculate a sustainability score, like I mentioned at the beginning, where we're taking these indicators that we found, and then we're aggregating them. So we're normalizing, weighting, and aggregating them into a single number. This is our sustainability score. And then we're going to look at the deviations in each subnational administrative unit from the expected value or from the mean. And then we're going to say that bright spots are places that are 1 to 2 standard deviations above the mean. So once we've found these bright spots, we can dig into them a little bit more and try to understand why they occur. And then the goal of this is to eventually be able to apply the lessons that we've learned to other places to improve sustainability in those places. Thanks.
Thanks, Julie. We have time. That was really quick.
It was a flash talk.
Yes, thank you. And we have time for 1 or 2 questions. Okay, sorry. I have to bring it. Could we have a third microphone? Maybe. Where was the question? Okay.
Hi, Julie. I'm Jess from Oxford. Nice to meet you. This was really interesting, and I know you had very little time, but the thing that I'm most curious about is how you chose which categories to include in your indicator. So if you could just say a little bit about that.
Yes, this took actually a lot of thinking to try to categorize different things, and I haven't shown all of the different categories that I've tried to code in the indicator list that we have. In our group, we just talk a lot about the different dimensions of sustainability, and this is kind of a key framework that we use in our work. So that was one of them that we wanted to make sure that we were covering the dimensions. We were also interested in the food system sector because originally the project was supposed to be bright spots of sustainable agriculture, but as it has evolved, we've broadened it to the whole food system, so we wanted to make sure we were capturing that. Other things that we're looking at are whether the indicators are practice indicators or outcome indicators. Yeah, off the top of my head, those are the main ones, but there's many things that we're trying to code. Also, especially in the literature review part, like who is developing these indicator frameworks? Is it involving a lot of participation or is it very top-down, that kind of stuff? So, yes, we've thought about many things, but didn't get to present them all.
Any other questions? Okay. Oh, lots of questions. Can you start speaking up? I'll be right there. Yeah.
You talked about what the indicators for sustainability. What the indicators for sustainability were, because on the one hand, you have this rigorous literature search that has all these experts defining sustainability, and on the other hand, you're asking the people who farm, "Hey, what do you think?" And I have an oyster farm. If you ask me what I think farms should be more profitable, and I think people should eat more oysters. And so, incorporating those answers into your definition, is that going to skew it in a way that might not lead to a better system ultimately?
Yeah, this is a super good question. Actually, when we ran our workshops, we didn't even use the word sustainability. We said, what would a desirable future food system look like? Because we didn't want to like skew their responses too much. But if these are indicators of things that matter to people on the ground, they're things that we want to be measuring. But yes, then we need to kind of think about, are we actually truly representing sustainability, or is it something else that we're representing? Thank you.
Thanks. One last question.
Thank you. Hi, I'm Annie from the University of Edinburgh. Could you give some quick examples of the bright spots you found, and if you did some investigation of what the kind of drivers or background to those places were that made them sustainable? And quickly on the indicators, I also wondered about when people give a response about what they envisage, they're quite bound by the current kind of economic system that they live under. I wonder if like you explored a brighter future through ideas of food sovereignty that might not be in like the average person's response, but that might be a vision like beyond current structures that might be more sustainable in some eyes as well. Sorry for the two-part.
Yes. Okay, the first question, could I tell you about any bright spots? I wish, but we haven't gotten that far yet. So come talk to me in hopefully a year. And for the second question, I think I would direct you to my colleague Annalise. She has a talk later today. Yes, later today. The 4 p.m. session with Emily. There we go. Go talk to Annalise. She's the one who kind of designed and ran the workshops and can give you a little bit more insight as to like the visioning exercise that was run with these participants to understand their visions of the future.
Thank you, Julie, again. And now it's all smoothly going. So the next speaker is Ranjan, who is going to talk about the transformation of the food system in India. Thanks, Ranjan.
Thank you everyone. I think there is a competition now for who will finish quicker. So I'm under tremendous pressure. So you really made my life tough, Julie. But thank you very much. We are part of this work is part of a larger Fable consortium. I don't have the time to introduce this, but I think all of you probably know, hosted by SDSN. We are a consortium of 22 plus countries. We try to come together and do integrated assessment modeling, and also using a calculator framework to basically, look at how the food systems are at the present and how they're going to, what are the pathways for transformation going forward to 2050, the projections. But the interesting part is that we try to work together in scenario marathons, and we try to integrate data together and see how we can achieve a global equilibrium or goals together. So that's the larger Teamwork Fable, what we do. This is part of a more specific work on the Food Systems Economics Commission, where we try to see if the food system transformations which we are trying to achieve in the future, they are going to be sustainable, and what are the levers and what are the changes we need to do as compared to the baseline policies which are operating. And there could not be a better context than India, which has a very complex agricultural food system, agri-food systems. Again, no need to go into the details, but all of you know India is a large country with a big population and very important player in the agricultural sector globally, but also paradoxically and for people in Mexico, from what I heard, we had a session yesterday by an agricultural economist from Mexico. So we have a very similar situation in India, where we are mostly smallholder farmers, and that leads to a lot of constraints in terms of bringing any change, because we have production side issues, but we also have consumption side issues, and farmers are also producers, but also beneficiaries of a lot of welfare schemes, because they're obviously not on the higher order of the socioeconomic strata. So we have different basically constraints on the food systems. We have an issue of food affordability. As we said, food has to be affordable. Farmers, especially those in the larger agroecological systems, their livelihoods, it's important to take care. There are inequalities, there is a market concentration. So all of these aspects are there. And we have also policies which work in silos. Okay, so this is where we are coming in, right? We need to balance priorities in terms of designing a food system that ensures that there is availability of food, because projections say that population is going to increase. We need to also move from food to nutrition security. We need to achieve environmental sustainability. This is of course very difficult to achieve. This needs coordinated, coherent policy action. We don't know where this will lie, but this kind of an exercise is towards helping. So this is the Food Systems Economics Commission. This is, we adopt an integrated model where basically MACPI, hosted by the Potsdam Institute of Climate Change. I won't go into the details of this, but for this assessment modeling we take a lot of inputs from 5 or 6 different models. So this is a picture for that. This is a MACPI model. Many of you may be familiar with this. This is a partial equilibrium model. Again, I will go into this. What is important here is that we try to have a baseline scenario, which is SSP2, for all of you who are aware of this. And we introduce food system measures to basically look at whether we can achieve or what kind of impact these measures will have on 4 important pillars. That's health, environment, inclusion, right? So inclusivity of farmers and also the economy overall. So basically this is a first of its kind integrated model for a large context for India specifically. And the interventions, the measures are on diets. So there are dietary measures. For example, we include in the model, if you are shifting from the traditional current dietary scenarios to eat Lancet diets, then what the impacts will be. So, these are the measures we try to include. I won't go into the details. Livelihood measures, so we introduce minimum wages, we introduce biodiversity protection measures, for example, land conservation. We introduce agricultural production measures, for example, if we want to reduce nitrogen. And all of these are linked to different policies we have in India already. So this is, basically a policy modeling exercise where we see if we introduce these policies, how it's going to go, and also, looking at different energy transitions and socio-economic developments. Okay. This is the results part, so I'll be, very quick on this. Basically, this shows, the top shows the impact categories: health, environment, inclusion, economy. I know it's a complicated figure slide, so let's not worry about it. All what we are seeing after this integrated modeling exercise, we see that having dietary measures, for example, moving towards more sustainable, healthy diets, in this case, Eat Lancet, if we adopt the Eat Lancet recommendations, there are positive effects, right? There are positive health effects, there are positive environmental effects, they are inclusive, and also have a positive impact on the economy. So all the greens are positive, all the orange and the reds are negative impacts, mild negative impacts and strong negative impacts. If we introduce livelihood measures, for example, have basic minimum wages, for example, there are a slew of measures. So I'm just cherry picking examples. For example, minimum wages, they also have positive effects on the environment, but they have an impact, slightly negative impact on agricultural employment, and also lead to higher food expenditures because food becomes expensive. We also have, positive impacts of biospheres all across, but agriculture, introducing policies which make agriculture more sustainable, actually has a negative impact on, a negative impact mostly on, on economy and inclusion, as you will see in the 4th pattern. So there are very interesting trade-offs. So health outcomes, again, to summarize, health outcomes improve, livelihood opportunities increase by 2050, changing diets, they lead to positive environmental impacts, and so we also have liberal trade policies, which means we are allowing for imports of food which are very, very intensive to produce in India. And if we do that, then we again have positive impacts also if we implement, improved livestock management. So basically, this very complicated exercise is trying to show the advantages and the trade-offs with all these aspects as we see. So we create a package for food system transformation, and we see that there are tremendous co-benefits. And just 30 more seconds. And these are the levers of change. For example, moving towards a healthier diet regime, or avoiding land use changes, and also increasing agricultural wages. They have a tremendous role, and therefore we need to reset the incentives or repurpose the government support for agriculture, and we also have to prioritize food system transformation for an overall sustainable scenario by 2050. That's what our results are showing there. Thank you very much.
Yeah, microphone.
So thanks to the presenters before me and to the organizers for troubleshooting. This presentation is actually designed to talk about how we build global crop maps. Pardon? Oh, okay, sorry. Yeah. So it is for those who are not aware of how global crop maps are built, and for those who have been doing it for quite some time, like how I am thinking about how we are moving forward in this direction. And you can tell me later whether you agree, the way I've designed this. So when I talk about the fourth generation, that means there must have been like a first generation, a second generation, a third generation, and then we are trying to reach the fourth generation. So this is like an example of how a first generation global crop map may be. It is just cropland. So where crops are grown, or crops, and there are various definitions of crop itself. The FAO has a definition, different folks have different definitions. So this is from the University of Maryland's 30-meter grid cell cropland maps, and I've just mapped the year 2019. But of course, there is a history behind it. So if you come across just a cropland map, that is like a first generation. You just know okay, here we have in this part of the world cropland. So the Sahara Desert, you will not make a mistake of saying there is some cropland there, or way not. So this is like a first generation. The second generation took place when we were able to start telling what is actually that cropland. So this is a map of year 2019 global maize, and I'm still working on it, but I've worked many times before also in the past. So you see in the very much north, like in Finland, Sweden, Norway, and also in the UK, it is just cropland and there is no maize. So this is how maize should look like. There should not be maize in Finland, essentially, or in the United Kingdom. So when you are able to do this, what is actually on as the cropland? Is it maize? Is it corn? Or is it rice? That is like a second generation. And it took a lot of effort and time, like a decade-long effort to go from the first generation to the second generation. Then you come to the third generation. Okay, so the second generation had one more advantage. You also started to build what is the crop yield. So the productivity of that crop on these croplands. And it's important to know that, because you talk about food security, you need to know not just where the crop is harvested, but also its productivity. So the second generation was for year 2000 or around the year 2020, single years or circa years, how much, where the crops were harvested, what its productivity was. The third generation was when you started to, forgot my own presentation. So here's an example of Naveen is maybe not here right now. So Naveen and John Foley built one of the first generation maps of where croplands were. And this is way long back, 1999 for the year 1992. So after a lot of effort, and there are other teams also who build cropland maps, and they're still building, and there is accuracy and improvement in just mapping the cropland itself. So there are generations of that also at the same time. So here's another example of like a second generation map. So this is Naveen student, Manfreda, Chad Manfreda and others who try to map for the first time like crop types all across the world. So then you come to the third generation. Third generation is when you start to look at it as a time series of how crops were changing all across the world. And then if you want to do analysis with like time series, then you can look at like what is happening to crop yields around all across the world and the impact of say climate change on crop yields across the world. So then you come to like the fourth generation of crop mapping, in which you are starting to now come up with the remote sensing community who are trying to do the crop type mapping and the statistical crop type mapping community and bringing them together at the same time, taking advantages of both of them. So the top part is like the remote sensing approach. Biggest stumbling block is labels. And at the bottom is like the statistical mapping, which I do and many other folks do. And our biggest stumbling block is like collecting all the, census reports. So this fourth generation is when you're trying to integrate all of them together and informing each other. And this is how you can do it. So here's the Central Valley of California. And this is like the cropland grid cells along the Central Valley of California. If I map it using my like a third generation kind of an approach, or I really don't know within each administrative unit where exactly is corn, then I'll probably map corn areas like this. But you have the CDL, and in this CDL, which is derived from remote sensing technologies, you have these yellow grid cells at very high resolution saying where is actually the corn. So if you utilize that information, then you map your 5-minute grid cell of corn more accurately. Remember, the CDL and remote sensing technology are not able to tell us the yield information. So you have the spatial accuracy, but you still don't know the yield. And that is still that's like a 5th generation kind of a challenge, not addressed it yet. So if you had mapped it just using the cropland information, in many of the minor, outlying areas, your accuracy will be less. But if you use the 4th generation, your accuracy suddenly begins to improve. So our method then, if you use the 4th generation, you have like the 2 times of a fusion, etc. Almost finished. Thank you for reminding me. So essentially what I'm trying to say, remote sensing approaches are making a lot of progress, but there are lots of challenges. There's often a challenge of overestimating the major crops. So if you're trying to map corn in the United States, you'll tend to overestimate corn. And in India, you'll tend to overestimate rice or wheat. And you will miss out all the minor crops. So there is a challenge in remote sensing. Statistical approaches will tell you where it is, but then the administrative unit level, but you cannot go down far below. So you try to take advantage of both of those 2 approaches. Finally, a plug to my project, which is actually supporting this kind of a work. So we have a project supported by the World Resources Institute working with IFPRI, that is Liangji and myself, our team together. We are trying to build this, so we all want to answer planetary scale questions, and then write these great papers in Science and Nature. But in the center is this massive ocean, which is like the data. Where is that damn data? So we have been supported by the World Resources Institute, and we are working hard to build that damn data as like the 4th generation. And here is some of the crops which we are focusing on. They are cereal crops, there are vegetable, fruits, there are plantation crops, oilseed crops, pulses. And so thank you for your attention.
Thanks, Deepak. We have time for 1 or 2 questions for Deepak on the global crop mapping.
Thank you very much, and excellent talk. And I can't agree with you more on the generations, because it's can be repetitive of cropland mapping. Have to go a bit further, and with so many available products, how do you see who are the users of global maps and how it's being used afterwards, after we produce it?
Yeah, so there are many research teams all around the world who are trying to work on crop type mapping with satellite remote sensing, not just in the United States, in Brazil, in India, in China. Australian census has moved to actually a remote sensing technique from 2023 season. So they are no longer collecting the census information from the ground. The use of the stakeholders who are going to use it. So there are the people who take decisions at the ground level, so they need very high resolution information. So my collaborator Liangji Yao from SNAN team, he is very good in that aspect. I have concentrated mostly in the past to build the time series information because I needed to do the scientific investigation. Or you can answer n number of questions if you have a time series. The difficulty is to actually build the data itself. So what we are saying is like, we will build the data for you. Just hold on a little bit more.
We have time for one more question on the maps at the back. We tried to get a cell microphone, but didn't happen. That's okay.
Thank you. Claudia Parra from food and beverage company Olan Food Ingredients. I'm one of the stakeholders using this data. So we actually have some collaborations with WRI, and I wonder, I know you had a little time, if you can share a little bit on the developments and when do you expect this to be released. I heard like they are doing some collaborations with Meta, with Google, that have high resolution imagery. We're waiting, honestly, for this.
Okay, yeah, of course. We are ourselves also very unhappy that we can't move faster. But this is a very challenging topic. The remote sensing aspect, high resolution one, as I said, is primarily the labels. You need to get the labels correct. So I have my own ideas of how we can use the labels from our statistical approach. Like, for example, the municipal level information of the various crops for different countries and how that can be used potentially as a label to speed up the process of crop type mapping, because that is where the problem is, the label problem. But even if you are able to do the crop type map accurately, you still have one more problem remaining, the yield. What is the productivity? So that is even more difficult problem in my opinion. So the timeline, our timeline is probably around the end or later part of 2025 is when we are supposed to deliver our products. It will be open access and possibly through the WRI itself. The years, our primary focus years for the data is every year from 2010 to 2020. But that is not going to restrict us necessarily because we are all scientists and we are all overachievers.
Thank you, Deepak. I think everybody wrote that down. The next speaker is Jeannie. Welcome.
Thank you. I'd love to be on that early subscriber list, Deepak, if you don't mind. If that's possible. Awesome. Hi. I'm just going to start my timer here.
I'll show you the minutes.
Great, thank you. Hi, my name is Kimberly. I am a postdoc at the University of Colorado Boulder, and I'm going to talk a little bit today about some global climate analogs that we've been developing and a use case for identifying areas of major crops. So what are the motivations for this? So one of the reasons is that a lot of climate and land classification systems are quite coarse. There's often a perceived bias in terms of how classes are structured. And what often is missing is we don't understand the underlying mechanisms and the natural phenomena that are causing certain ways of being in terms of the climate and land classification. Machine learning, I know it's going to be a hot topic all week this week, is a method that's been shown to be useful in climate and in land for tasks such as classification, object generation, and natural language processing. So we thought we would try our hand at it as well. So what we decided to do was to employ a deep learning method called autoencoders to reduce the dimensionality of climate data. And so what happens, and I'll go into a little bit more after, is compressing the data resulting in a latent space representation. But first I'm just going to discuss our data. So what we did was we used 12 bioclimatic variables of the 19 that are available from WorldClim, and so this is at a 2.5 kilometer grid. And we had historical data going up all the way with CMIP data to 2100. We used the 12 instead of the full 19 just for dimension reasons because it was just a lot of data to work with, which I know is a nice problem to have. So what we did with the data is we decided to subdivide and patch it. So we patched this data from the very large rasters into smaller 16 by 16 chips or patches as we call them, and it had 12 channels, which were our 12 climate variables. So if you think of a regular RGB image, that's 3 channels, we did 12. And the reason for this is when you look at a lot of machine learning methods, they use, like the computer vision ones use images that they feed into a system and then they learn some kind of classification or labeling, or they try to represent that image through their system. And so that's why we decided to use these chips, so we could employ a lot of these models that already have some architectures that exist. So in terms of our autoencoder, one of the reasons we developed it is that we were able to get this compression function. Does this have a laser? Okay, so we were able to get the compression, which is the encoding network. So as you can see, the green and red image is just a 3-channel of one of our patches, and it's able to be compressed through different reductions, largely 2D convolutions, which is what I'm showing on the screen here. And so we end up with a lower dimensional representation of our data. So you go from something like 16 by 16 by 12 to 2 by 16. And then what happens is that we then flip that encoder, it becomes a decoder, and we're able to reconstruct the image that we first put into that system. And so while we don't care too much about the reconstruction, it is good to know that as in terms of having a loss function, that we're able to reconstruct it. So here we're using mean squared error to show that the image that we put in is the one that the autoencoder is able to spit out again. And then in terms of what we do with this, well, we can use it for looking at current analogs, we can look at future analogs, clustering, and there's a lot of potential other purposes with this when we develop a potential foundational climate model. So what I have here is a t-distributed stochastic neighbor embedding plot of the historical data. And so all this is just a kind of lower dimensional representation of the data, and it's a nice way to kind of look at your data before you send it through models to see kind of, I get a first idea of how it will behave and potentially how it will be ingested by the network. And then on top of that, now we have our CMIP6 data, which we then, after we train our model, put through. And we can see that already, without even processing this data, that there is some kind of distribution difference between the historical data and the CMIP6 data that we put in. So then what we did was we looked at the Euclidean distances between all of our patches, so all 150 plus thousand of them. And so we computed the Euclidean distance between all of them, and we took the average. And what we found was, you can see the distances for the historical data. And for this analysis, we just used one CMIP6 model, so GFDL, looking at SSP 3.7. And when we took the difference of the future and the past, we saw that there were actually quite a few areas where the analogs were increasing or reducing in distance. So there are actually more analogs showing up in the CMIP6 data compared to the historical data. So that shows that, well, potentially what could be happening here is that as places are likely getting warmer and wetter, there are potentially more areas that they're becoming more similar to. So we can see that, for example, in a lot. Sorry, this laser really just doesn't work. No? Oh, okay, yeah. So we can see in part of the Amazon and northern Brazil, actually, more analogs have appeared compared to the historical data. And lastly, I just want to touch on the case study of crop analogs. This is something we're still working on and refining. But first I'm going to talk about our image search. So what we were also able to do is now we can take any patch that we've developed, whether it's historical data or CMIP6 data, put it through our autoencoder, and we can get the top N analogs for that area of the world. Thanks. So that's something cool straight out of the model. And what we're developing now is being able to visualize all of the analogs, whether historical or looking into the future for any place in the world. And so that could be for other climate modeling purposes, but for our purposes, we're right now just using Manfreda or crop grids, so we have all of the crops grown for every one of our patches, so we're able to say what grows in that location now, and we're hoping down the line we can look at all of these other analogs and say what crops grow there. and look and see if there are areas potentially where there could be diversification, or more worryingly, areas where there are currently a lot of crops grown, but it might be be on that edge or that cusp of being viable for that particular variety. And that's all for me. Oh, sorry, no, I have takeaways. I have one more minute. Sorry, I got panicked there for a second. So the key takeaways is that these deep learning methods can provide insights into pattern recognition and capture some spatial temporal dynamics. There's much more to explore in terms of areas with either expanding or declining analogs. We really want to look at the cusp of areas that are coming potentially into production, but also those areas that are quite now at the edge or the extremes of being able to be viable for agriculture. And lastly, as I mentioned, some interesting initial insights on our analog shifts by growing regions, but lots more target locations and crops to explore. So that's exciting. Thanks very much. And I apologize for my voice, sorry, I'm just fighting a cold right now.
Thank you very much, Lily. We have time for questions. You stuck perfectly to time. I can see one there.
Thanks very much. Very interesting research. I'm Jinju from Deakin University. So I've been using these auto encoders in my research, and I have one question. I can see you are using 16 images, and they are used as bands.
Yes.
As I can see.
Yeah.
So my question is, do you ever consider the time series pattern? I mean, the years should have a time series pattern. For example, previous year, this year, and the next year. This inherited information could be lost if we treat them as equal bands. Do you have any consideration about that?
Yeah, that's the thing we're thinking about. So there are spatial temporal autoencoders. So if you can think of a video and how videos are now potentially being run through autoencoders, you could do the same thing where any one pixel, you see how it moves through time. And so that is something we have considered because there's a seasonality, of course, and that for some, for example, perennial crops determines whether you can have tree fruits there versus, something that's acre or like rotty crops. So yeah, that's something we're looking into. It's kind of at the cutting edge right now. And also into masked autoencoders because that's quite cool too. If you mask certain parts of your passion, the autoencoder has to, not be lazy and do a bit more learning and make a bit more connections in terms of how the embeddings are formed. I think that's an interesting approach we're looking at as well. Thanks.
Right. We have time for another question if there is one from the audience. I don't see any hands, so thank you again, Jenny. And I will just take this time before the last talk of this morning session to let you know that if you have any frustrations this morning that you didn't have time to talk to the speaker, that it was too fast and you have more questions to ask them, this session as a whole is not over. We have 2 more slots. So they will both be in this room, and now everything is set up, so it should be smoother. So the part B is this afternoon.
I am presenting on the evaluation of the suitability of conservation management practices using global data. I am Ozias from Alto University. Okay. I am a postdoc. Yes. So, I don't know how familiar you are about the concept of regenerative agriculture. This has received a lot of attention because of the adverse impact of conventional farming on the environment. Basically, the main focus is that this regenerative agriculture is an approach to cultivation that uses soil conservation as the entry point. But the main point is to contribute to multiple ecosystem services such as soil health restoration, climate protection, water bodies, and biodiversity protection. And basically, some of the practices are so, for example, agroforestry, cover crops, no tillage, and organic farming. And these practices which I may focus on my study have received a lot of attention. So my data that I use for this study is kind of meta-global analysis. And when we try to look into this data set, you have here on the y-axis the different observations from different studies. And the main question that we draw from these studies to answer the question whether there is a yield increase after this practice have been implemented or not, basically. That's what we are looking at. And so basically, when you look at the graph here, you'll see that there are some cases where there have been some decrease in yield, such as the anti-sustainable no-tillage. Also in the case of agroforestry, there have been decrease in yield after implementing these practices. And also there have been some increase in yield, such as the case of agroforestry and CC sustainable cover crops. And so there are some studies also which reported some natural impact after implementing these studies. So this raises the question on what are the factors which are responsible also the variability in the result in the literature, and also whether there are some locations which are much more suitable for implementing such practices as compared to other locations. So to answer these questions, we look at the global metadata from global analysis, and we focus for our independent variable on the effect size, and the effect size just means the ratio between the yield that's come from these practices as compared to the yield from the conventional farming. And as a dependent variable, we use graded data such as topography, soil properties, etc. And we use random forest as model to model this data set, and also we use quantitative regression to predict uncertainty for the prediction. So what is the criteria for suitability? We consider a particular location suitable for a specific management when we notice that the effect size is positive and also coupled with the lowest level of uncertainty. So concerning the what you see here is the random forest ranking of the most important factors, and based on what is called the Shapley value, this just talk about how much this variable affect the model output. So basically, when we pull all the data together, what we notice as the main factor is that the management, the impact of this management on the effect size is primarily moderated by climate. And you see here, for example, the precipitation of dryness quarter and the aridity. And what this is telling us is that most of these practices that we study here are much more critical when there's a situation of water stress. There comes to maybe stabilize the moisture for the crop to grow. But when we look more at the specific management, we see that mostly soil properties, topography was coming up. Even for no-tillage, where there is one climatic variable, it was in relation with the topography variable. So the conclusion here that we draw was that for this management, the local environment is much more critical, especially for soil properties and topography. They seem to prevent over global variables such as climate in the response of crops to these regenerative agricultural practices. So we try to map the effect size and the uncertainties. And here you have on the brown color the effect size where a location where the effect size was negative with different level of uncertainty, and the blue ones location where the effect size was positive with different level of uncertainty. Basically, what really striking is that agroforestry the cover crop presents kind of a very optimistic scenario with kind of a higher effect size with maybe low or major uncertainty, which is quite very optimistic. But when you go down to no-tillage and organic farming, you see that some locations will present negative yield, which are not seem not to be appropriate for such management. But then when you look at the no-tillage, you see that this has some area in, for example, North America or India has some blue colors looking, meaning that this location are appropriate for no-tillage. So when we put all of these four maps together, we got this suitability map. And basically what you see here is that no-tillage seem to have first a positive effect size and also the highest suitability coverage compared to the remaining. And followed by maybe the cover crops, which has the Sahel region of West Africa, Central Africa, seem to much more suitable compared to the remaining. We will also try to look at, okay, are there possibility to combine different practices for different locations? And what we notice is that cover crop and agroforestry seem to have been the highest coverage in terms of suitability, and most of the time we notice that they prevail in areas where no tillage was negative. So there seems to be an alternative for such management for no tillage. And then we notice that no tillage, cover crop, and agroforestry seem to have a positive coverage, suitability coverage in North Africa, especially in India as well, and some spots which are scattered in some area in Africa and Latin America. So, we noticed that actually that there is a specific area compared to the optimistic map that we saw about agroforestry before. When we consider this scenario, agroforestry seems to be much more suitable in the West Central region of Africa and some parts of China. So in conclusions, we see that regenerative agriculture, yes, but most of the time, the local condition of the field are much more important, especially the soil property and the topography where these practices are implemented. And the suitability much more dependent on the management and location. But I would like to finish with a caution quickly that regenerative agriculture practices are not all about yield. Most of the time, sometimes, even where the yield will be negative, maybe for the terms, for example, for the case of no tillage, instead of the time spectrum. Because for the first, maybe the first years of implementation, maybe 2 or 3 years, the organic matter is being built up. So it's kind of not the only focus. Sometimes the focus is on building the biodiversity or fighting against erosion. But into the perspective of food production, we needed to focus on yields. And the other aspect we are focusing on it on our awareness studies. So, gracias. Thanks for your attention.
Thank you very much, Osias. You're right, perfectly on time, so we have 2-3 minutes for questions. So, one of questions from the audience on Osias' presentation. Thank you.
Thank you very much. No, yeah, just a quick question on something you touched at the very end. What is what's the delay period between what's the delay period you use to measure the yield impact? Like how long time did you let pass before you were estimating the impacts of the change in practices on yields? And I'm asking because as you mentioned at the very end, sometimes you need sometimes there might be a temporal decrease or a short-term decrease before kind of the soil structure builds up again or whatever change might happen. So yeah, thank you.
Yeah, this is a very good question. The data that we have, because we got data from different sources. Some sources has some time input in it. Some other data does not have. So we're faced with as most of you know, which data to choose, whether we need to take into account the time component or not. But here we not really focus on the time component. We just focus on the effort size. So the data that we use is just an aggregate of the data set, basically. So it's varied maybe from 2 years after the adoption, 1 or 2 years after the adoption of the practices up to 30 years. But I agree that it will be much more interesting to differentiate the time scale and see whether it will we should be able now to take into account the time factor and separate it and see the trend in the effort size at the different location.
Thanks. We have time for one last question. Anyone? For Osias? I think you're ready for lunch.
Yes.
Okay, thank you again, Osias, and to all the speakers of this morning. And we see you here at 2:15.